So in this particular video, we have two objects attracted to each other gravitationally with the force of 2.5 times 10 to the negative 10 Newton when they are situated 0.25 meters apart. Let's just assume they are point masses. So here in part A, it says given that their total mass is 4 kilograms, find their individual masses. So right away, I noticed this one's a little bit different. It gives us the total mass of the system. It didn't tell us what M1 and M2 is. Okay, and then part B, it says what is the gravitational force if the attraction between two objects if they are placed 0.6 meters apart. Okay, so it increases the distance to 0.6 instead of 0.25. All right, so let's go ahead and crack out part A. So this one's a little more interesting. In order to do part A, we would just normally set up as usual Newton's gravitational law of attraction function. F of g is g m1 m2 over r squared. Here I have chosen to go with the variable given in the diagram. Here's m1, here's m2, and then the distance between their centers is known as r. So in the denominator, I just call that r. So once again, I'm just using information provided in the schematic. If a schematic is not given to you, you should definitely make choices for yourself. Okay. So in part A, it asks us to find the individual masses. So I know I'm supposed to be looking for M1 and M2, whatever their values are. So right away, algebraically, I'm going to go ahead and isolate for M1 and M2. I don't know both those variables, but I can just go ahead and get them by themselves. Okay. In order to do so, the first step I want to do is multiply both sides by r squared, but at the same time divide both sides by g. To get rid of r squared, multiply both sides by r squared. That brings r squared up to the numerator. And then this g, capital G, universal constant, is in the numerator. So to get rid of it, you would divide both sides by g. Hence, the capital G is now in the denominator on the left side. Once I get to here, you notice I have M1, M2. I don't know what M1 is. I don't know what M2 is. But that doesn't matter. What I do know is the left side of the function, because f of g is given, r is given, and g is the universal constant, which is given to you. Okay. Here, I'm just going to plug in values that are given to me. F of g is 2.5 times 10 to the negative 10 newtons, and then the radii, or the distance between the two centers, is given as 0.25 meters. I want to square that because the function itself is square, so don't forget the square there. And then divided by g, which is just 6.67 times 10 to the negative 11. Okay. Once we do that, we can simplify the numerator. So I'm just going to go ahead and do the calculator work one by one here real quick. 2.5 times 10 to the negative 10 times 0.25 squared. That's going to give us a product of 1.5625 times 10 to the negative 11. And then the denominator is the same because I haven't done anything. So I just simplify the numerator. And then from here, all we have to do is divide both these numbers. And then if you do it on your calculator, you should get a value of, excuse me, 0.234 kilograms square. Okay, so if you've seen my other videos, the units here will cancel out. The only units left over is kilogram square, which makes sense because mass times mass, which is kilogram times kilogram, should have units of kilogram square. But you notice here, I made a statement here. You're kind of stuck here, right? Once you get to here, you can't take it any farther. So hopefully you realize that you have M1 and M2, which are two unknowns. And you have just one statement. So that's a ding 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 that you cannot solve. However, what you can do though is utilize the information given in the problem as well. In part A, it says given that their total mass is 4 kilograms. So I don't know what M1 is and I don't know what M2 is, but I know that if I take the two masses, if I take M1 plus M2, that'll equal to 4 kilograms. Okay, so stick with facts as you practice these problems. So here I have a statement that's true. I have M total, which is M1 plus M2. I don't know what M1 is. I don't know what M2 is, so I'm going to leave the right side the equal sign as unknowns. What I do know, though, is that M total is 4 kilograms. Okay, so as long as it adds up to 4 kilograms, you're in business. So what I can what I can do, though, is make a choice. Once you get to here, though, you have to make a choice, okay? You can either solve for M1 or M2. It doesn't really matter. Here, I've chosen to solve for M2 because I'm just going to go ahead and solve for M1 first, and then that's all. So once you get to this point, if you choose to, you could isolate for M1. I just made a choice to isolate for M2. In order to isolate for M2, here's M1. This is positive, so I'm going to move it to the left side of the equal sign, which makes it negative. So I have 4 kilogram, which is in the top here. and I'm on a minus m1. Okay, so therefore that equals to m2. Now I can use the function that I previously derived on the left side. I have 0.234 equals the m1 times m2. Well, I just solved for m2, so what I can do is substitute in. So wherever m2 is, I can say that m2 is 4 kilograms minus m1. So if you substitute carefully and you make sure your algebra is careful, you should be okay. So instead of m2, I use in parentheses here. Use parentheses when you substitute. Instead of m2, I wrote 4 kilogram, which is up here, minus m1, because that's what it's equal to, and then close parentheses. But once you get to here, though, if you introduce parentheses, as you should, you notice that you have to distribute. Okay, you have a variable on the front of parentheses, so therefore I'm going to distribute, and then I'm going to distribute to both the terms inside the parentheses. So m1 times 4 is just 4m1. And then m1 times negative m1 is negative m1 squared. So if I simplify my work here m1 times 4, which is just 4 times m1, or m1 times 4, doesn't really matter, you're multiplying. Here I just like to write the coefficient in the front of the variable, okay? And then m times negative m1 times negative m1 is negative m1 squared. So you notice here, hopefully, if you've been keeping up throughout the year, you hopefully recognize that this is a quadratic function. You have m1 square. M1 is your unknown and it's square. The second term here has an m1 that is not square, and then here you have some coefficient. So hopefully this triggers quadratic just by the formatting of the function. What I can do though is I can rearrange it so that the highest term goes first. So here I notice I have negative m1 square. I want to move this negative m1 square to the left side, and that'll be my first term because quadratic, you write the term with the highest exponent first. In this case, m1 squared is the term with the highest exponent. So don't forget to change sign as you move variables to the opposite side of the equal sign. So this is negative m1 squared. Moving it to the left side of the equal sign, change it to positive. And then this is a positive 4 kilogram times m1. I'm going to move it to the left side, and that becomes negative 4m1. And then the coefficient here is a positive, so I'm just going to keep that as a positive because I haven't moved it yet, and I'm going to set the whole thing equal to 0. Okay. Here I just left out the units just to keep it clean. So all I did was I wrote m1 squared minus 4m1 plus 0.234. Well, this is quadratic. Right? To do quadratic, you need to be able to pull out your coefficients correctly. So here in front of m1 squared, I don't see a number, so that coefficient is going to be a 1. In front of m1, I see a coefficient of negative 4. So it's important that you see the negative sign in front of the coefficient. Okay. And then this coefficient here is just 0.234. So here my A is 1, my B is negative 4, and then my C is 0.234. So I'm going to exit the screen, and we're going to do quadratic real quick. Okay. So as I said earlier, A is 1, B is negative 4, and then C is 0.234. And we hit calculate. It's going to output 2 answers, right? Quadratic always output 2 answers. Here, x is going to be 3.94, and then the other one's going to be about 0.06, okay? So 0.06 is 0.059, so I'm just going to round that up to 0.06. It doesn't really matter. All right, so that's that. And let's go ahead and go back to our stuff here. Alright, so if you kept up, once you get to here, once again, you do quadratic, and then quadratic is going to give us 2 values. Here, m1 is either going to be 3.94 or 0.06. Well, I don't know. The problem didn't say if m1 is the large one or the small one. It just says that their individual masses add up to 4. Okay, so I cannot make any assumption that m1 is the big one or the small one. So here I made 2 statements for you. I said that if m1 is the larger mass, then m1 would equal to 3.94 kilograms. Because quadratic gives us 2 values. 3.94 is greater than 0.09. No, it's 0.06. Okay. But if m1 is 3.94 kilograms, then m2 would have to be the other mass because they have to add up to 4. Okay. However, if m1 is the smaller mass, then m1 will be 0.06. And if m1 is 0.06, then m2 is the remaining mass, which in this case would be 3.94. So depending on how the problem is worded, you can have one of two answers, okay? So M1 can either be 3.94 or 0.06 based on whether it specifies if M1 is a larger or smaller mass. All right, so that is that. So that is the answer for part A, okay? See, I don't know which is which, so I'm just going to highlight both statements for you. B, asks us what is the gravitational force between the two objects if they are placed 0.6 meters apart. Well, I noticed right away 0.6 meters is greater than 0.25. So in order to figure out the coefficient, I would just take 0.6 divided by 0.25. Because by doing so, it allows me to set up a ratio problem. So here I have f of g nu, which is equal to g m1 m2. The numerator stays the same because it only compares the distance of the two masses, okay? The 2.4 simply comes from taking 0.6, right? The second distance here is longer, so I'm going to take 0.6. I'm going to divide it by the original distance, which is 0.25, and that will give me the multiplier of r, okay? So in this case, if you do that correctly, 0.6 divided by 0.25, you get 2.4. 2.4 what? 2.4 times the original distance, all right? And then the exponents on the outside, so I highlighted the 2.4 in the exponent because you need to be able to distribute the exponent to both of the 2.4 and the r. So therefore 2.4 squared is going to be 5.76, and then r squared is just r squared. But once you get to here though, 5.76 is the coefficient. It happens to be in the denominator, so I like to pull it out in front of the function, which it will be 1 over 5.76. And then the rest of the stuff here, g m1 m2 over r squared, that's going to be my f of g, right? Because earlier here in the comparison, we said f of g is g m1 m2 over r squared. So wherever g m1 m2 over r squared is, I can simply replace it by f of g. But once you get to here though, 1 times f of g is just f of g, and then the 5.76 in the denominator remains in the denominator. So that is our answer. So it'll be f of g divided by 5.76, okay? All right, other than that, I hope that helps. Stay nerdy, don't be whack.